why we have to learn about this new data structure? That is a question. So already we have seen the data structures like arrays, lists, wherein we observe the features like when you want to perform the operations on arrays and lists, they allow us to add a new element into the array or remove or delete any element from the array from any position in the array. Like at the beginning of the array you can do the operations, or at the end you can do the operations, or in the from the middle of the list also you can do the operations. But if you see many of the frequent computer science related applications, we need to we find situations like recursion and expression evaluation and expression conversions and all. In that situations we need a data structure which allows us to perform the operations only from one end of the list. It is not that in all the locations we can do the operations. So for that situation we need to find a new data structure which restrict the operations to be performed only through one end. For that, one solution is a stack data structure. So if you see it, definition of stack. First of all, stack is a linear data structure. It comes under the classification of linear data structure with list of elements. With list of elements, wherein it allows us to perform insertion and deletion operations only from one end. One end which is named as top end. So the definition is saying that it's a linear data structure with list of elements, with list of values, wherein in the data structure allows us to perform either insertion or deletion operations only through one end. That end is technically named as top end. For this stack, some general examples we can discuss. You can consider some pile of coins. Coins, if they are arranged as a pile one above another, like so we'll be placing one coin and above that we can place another coin. When our requirement is to follow a structure which is piled, it is possible that a new coin you can add only on the top. It is not that you can insert a new coin in between which disturbs the whole coin structure. So you can insert a new coin here. If you want to take a coin from this pile, the top coin is preferred to take it out. Or you can consider another general example, pile of books, one above another like this. When you are arranging books in this order, if a new book is there, to put in the structure where we can put that new book is on the top of the previous book. Like this, only from the top end we are performing insertion, and if you want any book, it is preferred to take the top book from the pile. These are the two general examples which makes us clear about the concept stack. Then stack operations, and we have the terminology here, push and pop. push and pop. Push is that in inserting a new element into the stack is defined as push operation. Inserting a new element into the stack through the top and is defined as push operation. Deleting one element from the stack through the top and is defined as pop. So we have seen the terminology. One is top, push, pop. Now we'll see with an example how these push and pop operations are performed for an example. We'll consider the list data. With 5 values, 5 elements. So our stack is like this. We have our stack like this and we have 5 elements. So we can take the stack with the size of 5. So with 5 locations. This is our stack. Now we have to insert these elements into stack. So the first operation is insert of AA. We have to insert AA. And initially there are no elements in the stack. So our top is representing no top, no elements, no top. Now where we can insert our element, this is our first location to insert. So we have to push our element AA into this list. Then now in the list, in the stack there is one element that will become the top of the pile. So we can shift this top to AA. Now next element where we can insert is on the top of this AA. So next element BB, it will come on the top of AA. So top always it is referring to the topmost element in the stack. Now BB is referred at top. Next element CC we can insert here. So the top of the stack is CC. Next DD is insert here. And next E is inserted here, and this is our final top, and our stack size is limited to 5, so only 5 elements we can able to insert one after another through our top. Now coming for deletions. Already we have learned that this data structure doesn't allow us to delete any element from the stack. It is only possible the top element we can delete first. So here we can observe this E is the element first to be deleted. So I can observe here in your stack. This E is getting referred through top. So this deletion of E will be done. So here E gets deleted. After E is deleted, now our new top will be shifted to the below location. So our DD now it will become the next top. So now the possibility to delete the next element is upon DD. Like that, in that sequence only we can delete the elements. With integer data, let's have one more example. If you consider the list of integers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is the list we have taken, and the list size is 10 elements. For this list, we want to construct stack data structure by performing sequence of push and pop operations. Now we can have our stack with size 10. Initially, when there are no elements, top is referring to the beneath position, there are no elements. Now this is the data we have to perform stack insertion operations. Now first thing we have to do is we have to insert this 2. So it is the push of 2. Push of 2. Where we can push this element through top, and only we can push this element. Now there are no elements, so this below location will become the top. So this can be inserted here. So 2 can be inserted here. Now this will become our top. Next it is push of 4. Where 4 can be pushed on the top of the list. It can be. Here the list is having some elements. Above all the elements, whatever top location is free, there only it is possible to insert this. So we could understand that this is the position, this is the location where we can insert it. So 4 will come here. And then we'll get push of 6, and 6 will be inserted here, and this will become the top. Like this, 8 will come here, 10, 12, etc. And here we'll get 20, and this location is referred with top. What is that? Push of 20. Once all push operations completed, we can go for some sequence of pops. Here we'll consider 3 pop operations through which it is only possible the top 3 elements of the stack only can be deleted. By calling the first pop operation, you can observe that this 20 can be deleted from the stack. So after deleting 20, your top will go to the below position. So here we'll get this 18. After performing one pop operation, your 20 no more will be there, and your top refers to the below element 18. Then your second pop operation refers to the top element 18. After the second pop operation, your 18 is no more on the top, your 16 will be on the top. And to perform third pop operation, top is referring 16. Now it is possible to delete this 16 through your top, and 16 is no more top, your 14 will become your top. So this is all how you can perform push and pop operations for the given list of values in a stack data structure. Now we'll see array representation for the stack, and then we'll see the implementation of stack data structure. For the same data, we can see the array representation of stack data structure. We already know that array representation is defined with indexes and values. Now, already with the values we have seen the stack data structure, how it is defined. Now we are going to see defining the indexes for that. So it is our stack with 10 locations, and our top is referring here. And if you see that values are inserted like this. So as per array representation, what we can do is that for every value location we can assign an index here. So we know that array indexes starts from 0 onwards. So this first element gets an index 0, and this gets 1, 2, 3 like this. It will be 9, 8. So now onwards, this particular first location element can be referred with 0 index and this will be with 1 index like this. So our stack now given a representation of array, and initially when there are no elements, it is referring to the beneath location which can be considered as -1. So now we have given top initial value -1 when there are no elements. When there are no elements. But when all the elements are filled, as you are inserting one element, once you inserted 2, this will be your top, which is 0, and this top value, it continues. Next it will become 1, like that it continues till it gets a value 9. So top, it gets the maximum index, maximum value as 9. So above this 9 it can't go because the maximum size is only 10. N is given as 10. So in order to see stack full of data, we can see that if top reaches 9, which is equivalent to n minus 1, we can say that our stack is full. When top is -1, we could see that empty stack. There are no values in the stack, and once top reaches the list size -1, we could see that our stack is full. So this is the array representation, and we could able to retrieve 2 conditions for stack full and stack empty. Now let's see implementation of stack using array data structure. So for the implementation, stack implementation, now we have to define push operation, the code for push and code for pop. First of all, if you consider push operation, it is that to insert new element into the stack. So the item to be inserted into the stack will take into the variable item. So it is that push should be defined with, we need to pass the item to be inserted for push. So for performing this push using array data structure, assume that this stack is defined with the array st of, assume that it is with some size 10. So now this is our stack with the index is 0, 1 like that. So initially there are no elements, top is -1, and now in order to perform push operation, we have to see that stack is having some empty locations or not. If an empty location is there, then only we can push data into the stack. So we have to check here the condition whether stack is full. If stack is already full, it is not possible to push a new element. So what is the condition for stack full? The size of the array, it is n, and if top reaches to size of the list -1, then we can say that all the locations in the stack, they are filled. There is no possibility to insert new elements. So for push, the initial condition we have to check is whether stack is full or not. So we have to check for this condition. So it is that if our top is equal to n-1, what we can conclude is that stack is already full. Else, it is the case that top did not reach n-1th location, there are some locations empty. Now, In the else case, when there are empty locations, assume that already here some element is inserted and top is referring 0, and here it is inserted, top is referring 1. Now this is the status of your stack. Now where you can insert your new element, your new item, assume that it is 10. Now where you will insert this 10, the top is referring 1, and you have to make top refers to 2, and into top 2 location you have to insert 10. So it is that top should be top equal to top plus 1. Now your top is 2 into st of 2. st of top, you have to place your 10. For this part you have to generalize the code here. So if it is the else case, it is not full, you have to make top incrementation, then into the array of that particular top position you have to pass your new item. This is the code we can write for push, and the initial condition what we have to check for push is that stack full. Then now we can move to pop. To define the code for pop operation of the stack, we already know that always pop operation is performed for the top of the stack. So assume that here now we have inserted 10 and our top is referring to 2 index, right? And like in order to delete an element, it should give a possibility that there are some elements in the stack. If the stack is not having any elements, if the stack is empty, is it possible to pop any elements from the stack? No. So how to check whether stack is empty or not? We already seen that when top is -1, initially when there are no elements in the stack, top value is -1. So this condition we can consider, we can take here to check whether stack is empty or not. For stack empty, the condition is top -1. So here we can check that condition first. If top is -1, we can say that stack is empty. So we can display a message, stack is empty. In the else case only, when there are some elements, we can now try to pop the element. Now what is the situation? We can pop this 10. Once this 10 is removed off from the list, our top should refer to the below value. Here top, the value is 2. We have to make it top -1 so that it refers to the next location 1. So first we have to take this element to be deleted. Here we will take the variable element. Element variable holds the value to be deleted from the stack. From which location we can get that? It is of st of top. Element to be deleted we can get from st of top. Then once we have retrieved this, our top should refer to the previous. For that what we have to do is that we have to make top equal to top -1. So here top equal to top -1. Now your top refers to 1. So this is the code we have to, this is how we can define generalized code for pop operation.